Okay, so you're gonna do an intro and then I'll just follow you.
Yep. Okay, so we should be good. I think everyone should be able to um see your screen now. Okay. Could I get a confirmation if you all can see the screen, please? If you could pop in the chat. Okay. Take that as a yes, a hand raise. Great. Okay. Thank you all for joining. We're gonna go ahead and get started with the webinar today. Um, I will pass it off to our host, Dan, in a minute. And to give some housekeeping reminders, the session is recorded and it will be emailed out to everyone who registered and attended today's session. We will have time for a Q&A at the end, and you can use the Q&A chat function on your screen to answer or to pop in any questions throughout the session and during the Q&A towards the end. So I will now pass it over to Dan to get us started.
Hello, hello. How's it going? Awesome, everyone can hear me. So, welcome to the NVD Divide, missing healthcare vulnerabilities and bridging gaps with LLMs. Little bit about me, if I can get this. Oh, thank you. There we go. I'm a software engineer at Medcrypt. I work on the vulnerability management and SBOM generation tool called Helm, and also for the past year, I've been working on our AI enhancement workflows as part of that tooling. I was the founder of MedISO and CyberProtect, which was an SBOM tool that was acquired by Medcrypt in 2020. So I've been doing this kind of stuff for a while. I have a patent on distributed SBOM communications. Basically, I think about SBOMs a lot. That's what I dream about. And I've also given talks at B-Sides and DEF CON about generative AI security and medical device threat modeling. First job out of college was for a medical device software company, and been doing it ever since. I love the medical industry, so everything has that tint to it, right? There's always, depending on what industry you're on, there's different things you got to think about, and I'm always coming from the medical device manufacturer side. So here's some definitions. A lot of these you're going to know, but I want to make sure we're all speaking the same language and you know what I'm talking about. So the first one is CVE. That's a number for a specific vulnerability. If someone's talking about, log4j or swine tooth or something, those are fancy names, but most vulnerabilities don't get marketing behind them that give it a name that everyone knows, right? So instead, if you want to make sure you're talking about the same vulnerability, you're going to use the CVE number that is assigned by a MITRE or a CNA, which is the next definition. A CNA is a group that has been blessed by MITRE and is able to assign CVEs to particular vulnerabilities. So it's not just one group doing it. They federate that out to multiple groups. They can be trade organizations, large companies like Microsoft, or like HackerOne if you're doing a bug bounty. So most bug bounty companies are also CNAs. They all have a scope associated with them, so they have their own little domain where they can issue CVE numbers, and that's how we keep things straight. CPE, Common Platform Enumeration, that's a standardized name for a single piece of software. I'll get into why that matters more later on in the presentation, but this basically, when you see a CPE, you know what piece of software someone is talking about, and that's typically what's used in CVEs. And then in CVSS, from the first group, it is a standardized framework for communicating security vulnerability scoring. So when we say 0 to 10, we know exactly how they arrived at that number and what that means for us. And then finally, the big thing we're going to be talking about a lot right now is CVE enrichment. That's where NIST takes a CVE from the CNA and they add their own authoritative CVSS, CWE, CPEs, and other information. So sometimes they change things, sometimes they add things. Typically, the CPE is is one of the things that they add because it's not attached to the original CVE vulnerability submission. And they basically standardize it and make sure it meets all the standards that you'd expect coming from the NVD. Here's a little breakdown also about like the flow of a vulnerability submission, right? So if a researcher discovers a vulnerability, they hopefully go through a vulnerability disclosure with the manufacturer or whoever it is they found the vulnerability in, right? Then after that, they'll go to a CNA to get the CVE assignment. That gets pushed over to MITRE, which then gets synchronized with NVD, hopefully enriched, and then is publicly available. So this is kind of the flow that you'd expect a vulnerability to go through until you finally get that number and everything's set and everyone goes, oh, there's a new vulnerability, there's a new CVE. So there's a problem that's been talked about a lot in the cybersecurity industry over the past year. which has been that the number of CVE submissions has grown substantially, and the ability of NIST to enrich those CVEs has actually gone down. So you can see this graph here starting from 2020, and most of these are vulnerabilities. So the dotted line is all the vulnerability submissions, and then the green one is all the CPEs that have been added by NIST during their enrichment process. The red one is ones where they haven't gone and added a CPE to it either because they can't figure it out or because they just haven't gotten around to it yet because they have a big backlog of them, right? This is sorted by published date. So you can see there's still some back in like 2020, 2021 that still don't have CPEs, right? And they're probably going to stay that way forever. But as we jump into 2023, 2024, this number jumps up a lot, the number with no CPEs. This pink line is our AI tool attempting to kind of pick up the slack and apply CPE matching information to things that don't have it. And you can see it does a pretty good job, especially with the newer ones, percentage wise of those that don't have CPEs. And the total number that do have CPEs is going, we expect this fall here because this is more recent. It can take time, but is not, where we'd like to see it, especially with the total number going up, right? Here's the same graph as a percentage to kind of give you an idea of the relative percentage of vulnerabilities coming in without CPEs, and how much we're able to enhance ourselves with our AI tool. So you might ask, why do we care about CPEs? Well, it's because when someone goes, oh no, there's a new CVE for the Arrow library. Our engineers say we use the Arrow library. Should we be worried? Is this even something we need to care about? Uh, did you mean the Arrow Rust object store? From Apache? That's for the CVE. Maybe for this CVE, you meant the R package for the same Apache Arrow tool, or maybe you meant PyArrow because you're using Python, and that so the CVE using PyArrow, or maybe you mean the Arrow KT project in Java, which when the CNA submitted it, they just put NA for the vendor and product name, so that's not very helpful. I got enriched later to be Arrow KT. Or maybe you mean Arrow maps with Arrow plugins. Or maybe all along when your engineers said they were using the Arrow library, they were actually using the Arrow datetime library because that is the Arrow library in the pip ecosystem that has no CVEs against it. And you just wasted a whole bunch of time trying to figure out whether you needed to worry about this when really you were using a totally different stack, right? So instead of saying, oh no, there's a CVE for the Arrow library, you want to say there's a CVE for this CPE, right? A Apache Arrow 1.3.0. That very, very unambiguously tells you here's what the vulnerability is in, and you can check whether you need to worry about it or not. What about pearls? So pearls are a newer format for identifying software in an unambiguous manner. I love them. They are great. Everyone should be aware of the Perl spec because you're going to be seeing more and more of them in different tooling. But they don't provide exactly the same thing as CPEs. So what they do provide very well is an unambiguous mapping from the Perl string to a software package. So if you're doing if you have an SBOM and you want to make a reproducible build, they're great. You can say, hey, we're using PyPy Arrow 1.3.0, and you know right away, okay, if I go to PyPy, because that's the ecosystem, I can pull Arrow 1.3.0, and I'm going to have exactly what this SBOM says, right? It's unambiguous. You know exactly what it's talking about. They're also great for matching vulnerabilities in an unambiguous manner. So if there's a CVE and it says it applies to PyPy Arrow at 1.3.0, and your SBOM says I have PyPy Arrow at 1.3.0, boom, match. You got it. You know you have to worry about it. You know you have to evaluate it. What they don't provide, though, is the opposite direction. They don't provide an unambiguous mapping from a software package to a Perl. So one software package can, and usually does, have multiple completely valid Perls that can reference that same software package. So if a CVE came out and it said, I have, there's a new vulnerability in GitHub/arrowpy/arrow at this git hash, right? This is a perfectly valid Perl that will appear if you look in osv.dev or any of the other databases. You will see Perls like this, and it tells you exactly what version the vulnerability is in. But if your SBOM says, oh, we have PyPy Arrow at 1.3.0, you can be like, oh, that's fine. We're not using it, right? No, you are. These actually reference the same piece of software. So this is it in PyPy, and this is the same exact piece of software at that hash, at that version in GitHub. So it's really good for one-on-one for validating. Yep, I have to worry about this, but you don't get the opposite. So you can get a lot of false negatives that way when really you should have evaluated it. And that's where CPEs really shine, is that it is authoritative, it is unambiguous. There's only one, hopefully only one name. Not always, it's not perfect, but 99% of the time, there's one name, right? And you might be asking, okay, well, why do we care about the NVD in general, right? There's other databases out there. Well, for one, the FDA cares about the NVD. It's explicitly called out in their pre-market and post-market cybersecurity guidances. And we definitely know it's referenced when they're evaluating pre-market submissions for cybersecurity. So other tools are great. You should use as many databases as you can because they're all slightly different and they all have slightly different strategies for doing things. But when it comes down to submitting to the FDA, you don't want to be caught in the situation where they go, "Hey, what about this CVE? Why isn't this in your report?" Right? And you go, "Oh, I don't know." Right? So you want to at least be aware of what is in the NVD so that you're not surprised if the FDA happens to reference it when they're looking at your pre-market submission. Further beyond just FDA specifically, it still really is the authoritative source for vulnerability information, despite all the problems it's been having lately. We still use CVEs a lot in the industry, and it likely will remain that way for a while because these things are slow to change. Speaking of slow to change, if you already have systems that ingest information from the NVD, it's going to be expensive to migrate to something new, and there's going to be trade-offs, just like that unexpected trade-off between CPE and pearls. You really have to think about it when you move. Okay, how are they doing things differently? What are they missing? What do I get that's new? And moving off of that is something you shouldn't do lightly. So legacy systems are likely going to continue to use NVD moving forward. So it is still something that we care about. So what do we do, right? We have this problem where they're not NVD isn't giving us the timely information that we need to link link CVEs to our SBOMs, but at the same time we don't want to just discount it and not use it anymore. Well, we can do our own self-enrichment. We can take information from other sources, link it up with the information we got from NVD, and get a more complete picture. So where do we get that? Where are these other sources we can get the information from? The first one is right from the horse's mouth. You can get it from MITRE at cve.org. They have their own database where you can download all the information that the CNAs submit to them. MITRE is encouraging CNAs to add CPE information ahead of time so that it's in their database before the NVD can get around to enriching it. So they're not every single one is doing it if you look through it, but more and more are, which is great because you don't have to wait around for someone else. You can get it right from the CNA. Hey, here's the CPE that is affected. They also provide this authorized data publisher schema where third parties can submit to MITRE and say, hey, the CNA didn't include this CPE or a whole bunch of other kinds of information. We are authorized, we are trusted. Here is our guess at what they meant for the CPE or the CWE or other information. So even if the CNA doesn't provide it, after some time, a third party might do your job for you and say, yeah, here's the CPE, and that's great. Outside of the MITRE CNA NVD environment, there are a whole host of other third-party enrichment databases like OSV.dev, the GitHub Security Advisory Database, or CISA Vulnerable, which is an ADP. So often, if it's here, you'll also see it right here in the MITRE database. Okay, so we have this data. How do we link it? Well, you can do it manually. You can go one by one. That sounds like a lot of work. I got a busy Friday. I'm not going to do that. So you can use a third-party tool like Helm, team I'm on, not a sales pitch, or SiftGripe, Cybeat, Sneak, Blackduck, Manifest, GitHub Code Security. There are a ton of SEA and SBOM tools out there that all are struggling with this problem and solving it in a different way. And they all have the same question around accuracy. What data sources are they using and how are they linking it with NVD CVE data, right? They're all going to do it differently. They're all going to have their own way. Some are going to be better than others. None are going to be perfect. I'm hoping what this talk is going to do is show you how we're doing it and give you an idea of the trade-offs that we're taking so that you can take that information back to whoever your third party is that you're trusting and saying, how are you doing this? What are the trade-offs? How is it better than what they're doing? How is it worse than what they're doing? So you can really get a good view of, knowing what you don't know. Because that's when it comes to cybersecurity, the unknown unknowns, what you don't know, is the thing that hurts you. If you know you don't know something, you can plan around it a lot better and you can manage that risk a lot better. And so all the tools that I was talking about have the same problem, right? How are we using these sources and how are we linking them? And it's gotten more complicated because the old matching process that all the tools would do in the past were we're going to match an SBOM entry, right? Something that we got from some tool that generated an SBOM to a CPE, and that's doing that box is doing a lot of heavy lifting, right? It could be directly from a CPE, it could be from a Perl, it could be packaging. There's a whole bunch of algorithms to do that matching. But once you have the CPE, you can just query the NVD, and you can get all the vulnerabilities out of the NVD because the CPEs are what the NVD speaks, right? And we can't really do that with these new vulnerabilities anymore. So now we need to generate a probable CPE for every single new CVE that comes in somehow, question mark, and then combine that with the entry data to be able to query the NVD, right? So this is a lot more complicated. It was already complicated, now it's even more complicated. And every tool, I don't care which tool you're using, is going to have to deal with this problem. They're going to do it in a slightly different way. So what do we need to do if what we want to do is take the CVE and turn it into something that our NVD pipeline can process? Well, here's the input that we're going to give it. We're going to give it all the information we can about a CVE, and here's the output that we want, right? We want like QEMU to turn into this CPE. Here's a case study. So I'm going to do this as a human manually. If I was going to do this like by myself, CVE 2025-0508. It is a vulnerability in a SageMaker workflow component that I happen to personally know is in Python, right? And it even says right here, human can make that distinction, right? It says Python. But if you look on the NVD, there's no enriched CPEs. There's no enriched CVSS score. The CNA did provide a CVSS score, which is helpful. But when it comes to matching, if I need to even think about looking at the CVSS score, I need to know whether I care about this, right? And I have to know that this would be the CPE we want to link it to, right? But as a human, I know that. How would I do this in a reproducible manner? Well, let's look at the first, like I said, right straight from the horse's mouth, right? Let's look at the MITRE database and see if we can find any information from the CNA. Well, CNA did not provide a CPE or a Perl, and it hasn't been enhanced by any ADP yet. So we're out of luck there. They did provide a vendor and a product information. So AWS, and it's AWS/SageMaker-Python.SDK. Wow, that looks an awful lot like the CPE. Could we just shove them together? Well, no, because then we're going to have this prefix there, right? So it's not as easy as just shoving the vendor and product information from the CNA together and calling it a CPE. You're going to get a lot of false negatives that way because it's not going to match exactly the CPE that was chosen for this particular piece of software. Okay, let's check out BuzzFeed.dev, right? That's a good combination of a whole bunch of different databases. Well, okay, there's no Perl provided. Oh, but there is a Git information. So we can look at the Git information and we can construct a Perl from that because we know its GitHub location, which is awesome and can help us match things. But this is also a Perl for it, right? So it's the same product with two Perls, and we weren't given this one. I just had to construct this one manually. And maybe we can search around, maybe we can find other Perls, and we can create a list of them. That's one way of doing things. We could do that, yeah. Just a list of Perls for a particular piece of software. Well, hey, why don't we go back and we do a search for previous vulnerabilities that share the same vendor product information that maybe they have a CPE attached to it, and we can pull that CPE forward to the new CVE, right? That's exactly that. Look at that. We have CVE 2024 34073. It on the NVD website, it has not been enriched yet, but Vulnrichment has gone through as an ADP and added this CPE to it. Yay, awesome, cool. So because Vulnrichment has gotten to add this information, we can now pull that forward because we know it affects the same piece of software, and we can apply that CPE to this CVE. Cool. So now we have a CPE. We know whether we need to worry about it or not based off our software bill of materials. That was a lot of time for a human to waste, and humans are expensive and lazy. Why don't we have an LLM do this? Because this is all string stuff, right? Like an LLM could totally handle this. So first naive solution, right? Let's take all the information we have about a CVE from public third parties, right? Put it into the context for a large language model and say, large language model, give me the CPE, please. Easy, super easy. Do that on the weekend, right? Done. Not quite. LLMs are very prone to hallucinations, and they will make up CPEs that, man, you look at them, you're like, that looks correct to me, but if you look into it, it's not. They just made it up. So you can't just ask it. You got to do some validation on it. And this is where we get into some more traditional string processing and data techniques. So we can do kind of like we did in the example I gave you, and build a historical mapping from common names used by CNAs to the CPEs that were eventually enriched by the NVD based on those names, right? So scrape the databases and create this mapping, do some set theory on it to come up with the most probable based on how many times we see it, right? Then we take that database and all the information, and for a particular CVE, look up the previous CPEs that could have been assigned to it, ordered by probability, combine them with another list that we can create based on the total list of CPEs and a text distance. Levenstein, Jaro-Winkler, etc. These are all very common techniques used when you're trying to find the similarities between two strings. That way we can find things that maybe the the CNA used a different vendor or product name than they'd used in the past. Maybe it's slightly different. So we want to make sure we don't do just a straight string compare. We want to make sure we are a little loosey-goosey about it and finding similar things in a fuzzy match, right? So by taking this list of probable based on exact match and probable based on a fuzzy match and providing that to the LLM and saying, hey, based off of all of the information in your context, which one on this list do you think is correct? Or if none of them are correct, tell me that. Now, you take that answer and you verify it's actually in the list because LLMs are sneaky and they will hallucinate again. And they will tell you something not in the list. What we found when we did roughly this process was a 79% accuracy when compared against already enriched 2023 data, 90% if you consider partial matches. So that's where maybe there were multiple pieces of software and it didn't get all of them, it just got like half of them, right? Then 90% success. 79% was we got exactly the same thing that NVD enriched. And LLMs are really, really good at fuzzy matching based on context. So one of the examples that I love to give is you have the JWX Go library, and in the vulnerability, the CVE description and all the context, it's listing Go and Golang a lot, right? Well, a tradition like there's two CPEs that could possibly be JWX project, JWX, or this listrat Go JWX. If we're just doing a string analysis, this one, which is the wrong one, the JWS project one, is going to win every time. It's closer text-wise, right? But the LLM is smart enough to see all the Golang references and go, actually, it's the correct CPE, which it is, even though it's a further text difference away from this other one, this wrong one. And that just blows my mind, right? Like, wow, it can kind of take context and apply it and make a better decision that way. Cool. So we have the name, we have the CPE, but we also need the version information because that's super important. If we're on a newer version and the vulnerabilities in an older version, we don't care, right? So we need to be able to take this kind of data, QEMU, before 8.2.0, and translate it into this super esoteric and complicated matching information that is the NVD format. So naive solution, right? Just say, hey, LLM, here's the context, generate the JSON for me. That actually works for a lot of simple ones, but for more complicated ones where there's a lot of different ranges in it, it fails horribly. It does not get the JSON right. There's little differences in it. But the thing is, formatting JSON, you don't need an LLM for that. That's really, really simple with traditional JSON libraries, right? If we could get the LLM to output to pull it all out and just put it in a more parsable format that's not English, that's something we can parse very easily, that it has been heavily trained on and can do very, very reliably, then we can take that and turn it into JSON ourselves, right? So how about like C-style Boolean expressions? LLMs have been trained extensively on code, so they should be very good at outputting those, right? And that's exactly what we saw. So here's an example from one of the more complicated CVE version information reports. It was a CVE in Juno OS, and it was this small version in this major rev, this small version in that major rev, this small version in that major rev, and this small version in that major rev, right? So because they applied patch to all their previous major versions, so it was able to parse that English that I just that was very complicated. And honestly, as a human, it's hard for me to go, okay, what version are we talking about now? And turn it into this Boolean expression of, less than this, or between these two, or between these, or between this, or between that. Or if you're on Juno OS Evolved, then this version, or that version, or that version, or that version, right? And now from that, we can turn this into JSON ourselves without needing an LLM to do it very, very easily using traditional parsing techniques like EBNF, which is a way of describing a grammar, right? Like a C Boolean expression, and parsing it yourself so that you can do whatever you want with it after you've parsed it. This is not the grammar that we used, and I am very, very ashamed to say that I didn't think of. I wrote the EBNF grammar myself after looking at after looking at the what the LLM was outputting. I didn't think, you know what an LLM would be really good at? Generating an EBNF grammar. So this is the EBNF grammar that Gemini Gemini generated, and I think it might actually be better than what I wrote. So I now take a look at that. There's an example, and they're like, oh, that's a pretty good example. So to kind of recap what we did, we can take something complicated like this English, ask the LLM to turn it into a C-style Boolean expression, which is a lot easier for us to parse with an EBNF grammar, and then parse that with an EBNF grammar, and finally turn that ourselves manually into what what the NVD would do, and boom, now we got it. Here's a recap of CVEs enriched by published date, and again, that pink line is what we're seeing, what we were able to add CVEs to that haven't been enriched yet. So to recap this part, NVD is currently unable to keep up with enrichment info. And as the main source, that is concerning. So what are we going to do about that? Well, other sources are very helpful in augmenting the NVD info that you get that's unenriched, but manually evaluating each one is time consuming and super error prone. You need to evaluate each one because you don't know what you don't know, right? So just doing a text search for things that you know is in your stack is not quite good enough. An LLM, if you properly prompt it, if you properly validate what it says, if you go through this process, it can effectively speed up enrichment efforts around CPE and version info, especially when you combine it with more traditional programming techniques. And also, there's some ancillary benefits to having all this data indexed and easily accessible, right? So we've done all this now to try and shore up this gap, but what more can we do with it, right? We have all this vulnerability information. Could we summarize mitigation techniques? Right? Maybe it can tell us, instead of me having to read the thing and parse it, I can get a summary of, hey, here's the things I need to do to help mitigate this vulnerability until we can upgrade to this version that the LLM knows we can upgrade to. Could we ask very esoteric, specific, non-obvious questions? And based on all the context that it got, all the references, all the third-party public databases. This one is the perfect example. It was a vulnerability that kept saying .NET. The vulnerability was in .NET version blah, .NET version blah. I'm like, okay, .NET Framework or .NET Core? And there was a whole bunch of reference information. I went, yo, LLM, for the CVE, is it .NET Framework or is it .NET Core? And the LLM was able to go through each one and say, look, nowhere in any of these references does it mention .NET Framework. So pretty certain it's .NET Core. And it also mentions PowerShell Core. So again, yeah, pretty sure it's .NET Core. That is something that would have taken me hours of sifting through documentation and trying to find information before I was confident in. And by having this and able to, again, validate, it's an LLM, it can hallucinate. So validate what it's saying here. Okay, do a search for PowerShell Core. Oh, I see that is referenced here, here, and here. Awesome. That just saved me like an hour of time to say, it's in .NET Core, we're using framework, different stack, don't need to care for this specific CVE. So we have all this data. Like, what else could we do with it? What would you like to do with it, right? Could we automate compliance documentation? Maybe take a first stab at it, and then a human only has to double check it. Could we do threat model rough drafts? Take a first stab at that, and again, a human only has to double check it. Maybe automate rescoring based on individual context. There's a lot of people that don't like CVSS for medical devices because CVSS scores things in the way that makes a lot of sense for traditional IT, but medical devices are very different when it comes to the threat landscape, right? So could we take a CVSS and information about a device and maybe automatically rescore it based off of what you know specifically about your device? There's a lot of stuff we could do with this data. And I'm really interested to hear your ideas and your questions about where it could, provide value and speed things up. And that's it. Happy to answer any questions about what we're doing. I'll answer as much as I can, and Kate will jump in and tell me to shut up if I'm giving away too much information, or future things we could do with this information now that it's easily indexable by large language models.
Thank you so much, Dan. So attendees, you can use the Q&A chat at the bottom of your screen and pop in any questions you have.
Also, props to whoever put Daniel Beard as their name. It's either your real name, in which case great name, or you thought you could get in and become me and get privileges, which is awesome. Right. Okay. So one of those is how does LLM-based approaches compare to traditional vulnerability analysis methods in terms of accuracy and reliability? Accuracy and reliability not as accurate, not as reliable as traditional techniques. The caveat being that traditional techniques involve a human looking at it and making a decision that a human can make, right? An expert who has done this over and over and over again. So is it as accurate or reliable as a human looking at it? Heck no. Is it orders of magnitude cheaper and faster and a great first draft? Heck yes. So that's really the sweet spot is can we get this fast? Can we filter out a whole bunch of stuff that doesn't make sense and then have the human to look at the either ambiguous cases that it can't figure out or the ones that it flags as maybe we want to look at. So it's a huge time saver, not necessarily a more accurate or precise solution. So one of the biggest challenges in using AI-driven solutions to address the NVD analysis gap and how can they be mitigated? So the biggest challenges right now are that CPEs, so we have all this historical data, right? And we can map pieces of software based on the CNA input to CPEs that were used in the past on previous CVEs. But what if there's a new vulnerability found in a new piece of software that doesn't have previous CVEs in it? Doesn't have, there's no previous CVEs, there's been no CPE assigned to it. The LLM in this situation, rightfully, most of the time will kind of throw its hands up and go, I can't assign, nothing in that list makes sense. This is a brand new one. So what we really need there is a faster way of assigning CPEs in a regimented fashion. And that could be vulnerable enrichment, as an ADP. If they can operate quickly enough, then we can wait until they, enhance it themselves, and then we get it. That could be a procedure. That could be a consensus model where we could guess, and someone else could guess, someone else could guess, and then we take whichever one's the most common one. But there really needs to be a way for new software because we can't wait around for months and months and months for NIST to get around to adding a CPE themselves if it's a brand new piece of software. Sweet. Any other questions? Anything you're confused about? I can go back and talk about anything. Okay. Well, unless there's one coming in, Kate, should I just call it?
Yeah, thank you all for joining. And if you have any other additional questions, feel free to email um, Dan, if you want to go to the next slide, you can show your contact information there. You can send an email or to info@medcrypt.com. And we will send out this recording as well after we conclude here. So thank you all again for joining.
Thanks, everyone.